Welcome to RDCS tutorials. In our previous class, we discussed scheduling criteria, FCFS and SJF scheduling. Today, we will continue our discussion with priority scheduling, round robin scheduling and multi-level queue scheduling. These are very important topics for UGC NET, PG set and other interviews. Okay. So before moving ahead, let's quick revise. FCFS execute process according to arrival order, whereas SJF executes the process with the shortest burst time first. SJF provides minimum average waiting time. Okay, today we will discuss these topics: priority scheduling, round robin scheduling, and multi-level scheduling. Now let's start. What is priority scheduling? So in priority scheduling, every process is assigned a priority value. Each and every process, there is some priority value is there. So we are assigning the priority value. The scheduler selects the process. So the scheduler will select the process with the highest priority and allocates the CPU it first. Which value is highest priority, then we will go to the CPU first. Unlike FCFS, arrival order is not the main factor. That priority becomes the deciding factor here. But FCFS, it is only from the starting arrival order, but there is no main factor. But in a priority scheduling, it becomes the what? It becomes the deciding factor. Okay. CP is allocated based on the priority and highest priority process will execute first. Okay. Next slide. Why priority scheduling is required? So why this scheduling is required? So not all processes are equally important. Each and every process, there are some advantages are there. So not all processes are equally important. For example, there is one system level process is there. Okay. System level process. System level process and security related tasks should receive CPU before less important background applications. Therefore, the priority scheduling is useful when some tasks are more critical than others. When it is required, when the some tasks are more critical. Okay, na? When more critical than others. Whenever the process are more critical than others, then we are using the priority scheduling. There are some important examples are there. Antivirus, in there we are using priority scheduling. System processor, is there any emergency task? For these all types of, we are using priority schedulings. Okay. So there is some real-time examples are there. The hospital emergency ward, critical patient, that highest priority, regular patient, lowest priority. Consider there is one example. Consider a hospital emergency room. There is one hospital emergency room is there. Okay. A patient with a heart attack. Okay, there is one patient. So what is that patient? We call critical patient. That patient is suffering from what? That patient with a heart attack. Patient with heart attack and a patient with a minor fever. What is the regular patient? Patient is suffering from the fever, that normal minor fever. So one patient is heart attack, patient with a heart attack and one patient with a minor fever. So even if the fever patient arrived earlier, so here the fever patient is there, that fever patient is arrived earlier before the critical patient, the fever patient arrived earlier. Okay, the doctor treats the heart attack patient first. Okay, here the doctor treats whom? The doctor is treating the critical patient, that heart attack patient first, because the emergency case has highest priority. Okay, this is exactly how priority scheduling works. So again I am telling, consider a hospital emergency room, a patient with a heart attack a patient with heart attack, a patient with a minor fever. Okay, even the fever patient arrived earlier also. The doctor treats the heart attack patient first because the emergency case has highest priority. This is the exactly how the priority scheduling is working. Okay. So I will give one example how in a system how priority scheduling is working. So there is priority scheduling. These are the processor P1, P2, P3 and P4 and these are the priorities. The P which one is the highest priority here? Priority the values. Which one process value is highest here? The P3 has highest priority value. So what is the priority value of the P3? It is equal to 4. So here which one is the highest priority? The P3 has the highest priority value. Then then after that what? Then the P1 is the highest priority value. Then after that it is followed by P4. The P4 is the highest priority and the last priority is P2. So the scheduler always check the priorities before assigning to the CPU. Okay. The scheduler every time it will checks the priorities before assigning the CPU. So here which one will execute, which one will assigning the CPU first? The P3 because it is the highest priority. Then what is the next highest priority? P1. So it will assign to the CPU. Then again P4 and again P2. This is the execution order for the priority scheduling. The priority scheduling, how it is working? Based on the priority values. Which one is the highest priority values? That will assign the CPU first. Okay. There are two types of priority schedulings are there. Primitive priority, primitive and non-primitive. There are two types, primitive and non-primitive. In primitive priority scheduling, the higher priority process can interrupt a currently running process. There may be an interruption between the primitive. Why the interruption will come? Whenever the current process is running, the highest priority process can interrupt that current running process. In non-primitive priority means a non-primitive priority schedule, once a process starts the execution, once the process starts the execution, it continue until completion, until it continues the completion. But primitive, if the highest priority process can interrupt, a currently running process will work. Okay, these are the two types of priority scheduling, primitive and non-primitive. The starvation problem. So the biggest disadvantage of priority scheduling is starvation. This starvation is the biggest disadvantage in a priority scheduling. If high priority process keep arriving continuously, so every time the high priority is only processing keep arriving the continuously. Okay, for example there are 3, 4 and 5. There are three highest priorities are there. Every time these highest priorities are only arriving the continuously, but low priority process may never get CPU access. This is the biggest problem. This problem we call as the starvation. Low priority process waits indefinitely. How much long we need to wait? That time we need to wait for the till to continue the process for the CPU. Okay, so whenever that highest priorities are continuously arriving to the CPU, so we need to wait until the process should be completed. So that we call as a lower priority process waits indefinitely. This problem we call as a starvation problem. Okay. So we'll give one real-time example for this problem, VIP queue. Okay. So what is VIP queue? The VIPs are there. You went some temple. So the VIPs are continuously arriving to the temple. The normal visitors keep waiting only until the VIPs will go out. This endless waiting is called the starvation. Okay. For this starvation, then what is the solution? For this starvation, there is one solution is there. That solution we call as a aging solution. Okay, for this starvation problem, the starvation problem will occur where the starvation problem will occur in a priority scheduling. For the starvation problem, we are giving one solution. That solution is called the aging solution. Okay, to solve the starvation, okay, to solve the starvation, okay, to solve the starvation, operating system will use what? The operating system will use the aging technique. As a process waits longer, its priority gradually increases. Whenever the process will wait the longer, okay, whenever the process will wait the longer, its priority it will gradually increases. Eventually, the process receives the CPU time. Okay, this is the aging solution. Round up. The next scheduling is round robin scheduling. The round robin scheduling is one of the most popular scheduling algorithm is used in a time sharing systems. Okay, the round robin scheduling is one of the most popular scheduling algorithm where we are using this round robin scheduling in a time sharing systems. In a time sharing systems, we are using round robin scheduling algorithm. Okay, so every process, okay, what is the round robin? Every process get a small fixed amount of CPU time called time quantum. Each and every process will fix some amount of CPU time. That fixed amount of CPU time we call as a time quantum. Okay, that we call as a time quantum. Then what is the time quantum? For example, the time quantum is which process the processor will execute how much time. That each and every process there is some fixed CPU time is there. That fixed CPU time we call as a time quantum. For example, I am giving some fixed CPU time 2 milliseconds. These 2 milliseconds we call as a time quantum. Okay, the time quantum determines how long a process can use the CPU before the scheduler switches to the another process. Again, I'm telling time quantum. The time quantum it is determines how long a process can use the CPU before the scheduler switches to the another process. Okay, the simple exam point of view I will give. The small quantum is nothing but the more context switching. Small quantum is nothing but the more quantum switching, and large quantum switching it is behave like a FCFS, first come first serve. Okay, then I will give an example for the round robin. These are the processor. Then what is the round robin? Each and every process there is some fixed CPU time is there. That fixed CPU time we call as a quantum time quantum. So here there are different types of processor there. P1, P2 and P3. What is the value for the P1? 5. And what is the value for the P2 is 4. What is the value for the P3 is 3. So each and every process we are giving some fixed time. The fixed time is what? Quantum 2. The 2 milliseconds we are giving the fixed time. So each every process get only 2 milliseconds. If a process is not completed in the 2 milliseconds, it returns to the ready queue again. This scheduler continues rotating a more process until all are the completed. Like this, there is a some round circular formation is there. Each and every process, if it is not completed only in a 2 milliseconds, it returns again go to the ready queue. The scheduler continues, it is rotating. The scheduler is continuing, it is rotating among process until all are completed. Okay. So what is the execution process? The which one quantum is equal to 2. P1 it is 5 value, so it will execute how many times? Or 2 milliseconds only, process only 2 milliseconds. Again P2 process only 2 milliseconds. Again P3 it will process only 2 milliseconds. If these 2 milliseconds these processes are not completed, again it is going to the previous one, that is in a ready queue. P1, P2 and P3 it is rotating only until the process should be completed. Okay. To the next slide, the context switching. Here we discuss the context switching in a round robin, right? So what is meaning of context switching? The context switching is nothing but when a CPU switches from one process to another process. When a CPU it switches from one process to another process. One process to another process. Which one? The CPU switches from one process to another process. The operating system will saves the current process information. So whenever it is switching from one to another, the operating system is there. The OS, the operating system will saves the current process information and loads the next process information. So it will save what? It will saves the current process and it will loads the which one? It will loads the next process information. These activity we called as a context switching. Are you getting my point? What is the context switching? The context switching is nothing but when a CPU switches from one process to another process, the operating system will save the current process and information and loads the next process information. These activity we call as a context switching. I will give a real-time example. So what is that? The teacher changes from the mathematics class to science class. So a time is required to switch. Yes, it is switching. The teacher is switching from the maths class to science class. This is nothing but the context switching. Okay. The next one. The advantages and disadvantages of round robin. What is the advantages? The round robin gives every process is a fair chance. What is the advantage? Every process will give a fair scheduling. That is nothing but the fair chance. Every process will get the equal chance. Fair is nothing but the equal chance. However, the excessive context switching can reduce the response. So here what is the disadvantages? These context switching will reduce the performance. That is the disadvantages. The performance depends from what? The performance it depends every time. It depends only the time quantum. This is nothing but one disadvantage. And here each and everything will get the same fair chance. Then the response time is good. These are the advantages and disadvantages of round robin algorithm. The next one is next scheduling is multi-level queue scheduling. Okay, what is the multi-level in the large system? So we are all discussing, we are connecting with the large systems only, right? The large system process are grouped into different categories. Each and every large processor, large system process are grouped into different categories. Each and every different categories we are coming into the group. Different categories. Okay, different grouped into the different categories. Instead of one queue, the multiple queues are maintained here. Instead of one queue, we are grouping means instead of one queue, we are using the we are maintaining the multiple queues. So in all, till now we discussed only the single queues, but here in a multi-level queue, we are using the multiple queues using maintained. Multiple queues are maintained here. Okay. Each and every process are available into multiple queues and different queues use the each and every different queue is using the different algorithms. Okay. Next one, there are different types of multi-level queues are there. Multi-level queue scheduling, foreground process, system process, interactive process, batch process, and background process. Each category of process has different requirements. Here, there are different queues are there. Each and every process, the requirement is different. Therefore, the different queues are maintained here. Okay, these are the types of multi-level queues. And I will give one real-time example. There is from airport queue system is there. The passengers are separated into different queues, right? In an airport, different passengers are there. The passengers are separated into different tickets. For example, two different tickets. VIP passengers will receive the higher. There is some VIP passengers are there in an airport. The VIP passengers will treat like what? Will treat receive the higher priority. Okay, highest priority VIP. And similarly, the process are divided into what? Multiple queues in a multi-level queue scheduling. So here only in a airport queue system, there are two types are there. Normal and VIP. The VIP will get the highest priority and normal will get the lowest priority. So here there are each and every process will divided into different category. Here how many different categories we divided? VIP and normal. So VIP passengers receive the highest. So similarly the processes are same like here. The processes are divided into multiple queues in a multiple queue scheduling. Okay, these are the important scheduling algorithms. And there is a comparison is there for the each and every. It is very important. Remember these 5 points carefully because they are frequently asked in UGC NET, TG set and university examination. So simple, you need to remember. If you are talking with FCFS, immediately you need to get it is a how it is working based on the convoy effect. SGF it is nothing but the minimum waiting time. The priority queue means what is the problem here in a priority? The starvation. So what is the solution in a aging solution to the starvation? How the round robin is working? The round robin process will working based on a time quantum. So remember these 5 points. Okay. Moving to the next slide. There are some important questions are there. These questions are repeatedly, regularly in competitive exam. Make sure you remember both the concepts and the reasons behind the answer. So which algorithm gives minimum average waiting time? The answer is SJF. SJF it stands for what? SJF it is nothing but shortest job first. Which algorithm use the time quantum? The round robin is using the time quantum. What is the time quantum? That each and every CPU process there is some fixed time is there. That fixed CPU time we call as a time quantum. Which algorithm suffers from starvation? The priority scheduling is suffering from the starvation problem because every time the highest priority will arriving continuously there is some starvation problem is there for the lowest priority. So what is the solution for the starvation? The aging is the solution for the starvation. These questions are repeatedly it is asking in a competitive exams. Okay, so keep remember. So thank you for watching. In this video help you understand CPU scheduling algorithms. Please like, share, comment and subscribe to RDCS tutorials. See you in the next lecture.